Okay. In math, or when you're multiplying these polynomials, there's a couple special ones that you run into a lot. If you do something a lot, what do you end up always doing? No matter what it is. If you do one thing over and over and over again, what do you always create? Muscle memory and shortcuts, right? Like that's what you do. Well, in math, it's the same thing. When you see the same kind of thing over and over and over again, we end up creating shortcuts for each other, for ourselves. So let's take a problem from the homework that was something like 3x plus 4 quantity squared. Okay? This type of problem actually has a name. Okay? We call it a perfect square trinomial. Now, the reason it's called that is not because of where we're starting, but it's actually where it's going to end up. Okay? This is going to end up in what we call a perfect square trinomial. Okay? So, how do you solve this? How do you multiply this out? What does that mean? 3x plus 4 squared means 3x plus 4 times 3x plus 4. So what are we going to get? We're going to get, which is 9x squared. We'd have a 12x. We'd have another 12x. And then a 16. And then what we would get is this, 9x squared, 24x, and a 16. This is actually known as a perfect square trinomial. When we do that, we actually end up wanting to give ourselves kind of a shortcut approach. Where did the 9x squared come from? In this problem, thinking, I actually, because I do this so often, I want to be able to create kind of a shortcut of, I don't want to have to write this out every time. I actually don't even want to have to FOIL it out. I want to be able to go right from here to the answer. So where did the 9x squared come from? It came from that first term squared, right? So basically what ends up happening is we're going to have this a plus b squared. Let's just take a general form. No numbers, no letters. A could be anything, B could be anything, right? In our perfect square trinomial, where we're looking for 3 terms, where did that first term come from? Where did the 9x squared come from? It came from that first term squared, didn't it? 3x times 3x? So the first term is going to be whatever that first term is squared. The first one's really easy. The last one's really easy. Where did the 16 come from? It came from the second term squared. It came from the 4 squared. So this one's easy, b squared. The middle term's a little bit harder. Where did the 24 come from? But where did the 12x and the 12x come from? So it came from these two things multiplied together. But these two things don't multiply together to equal 24. When we FOILed these out, a plus b, yeah, you get that a squared, but then you get an ab, and you get another ab, and then the b squared. So these two are easy. This one is going to be 2 of those. This will always be the form of anything squared like this. So it actually becomes really easy to FOIL these out. For example, if I give you something like 2x plus 3 squared, What's the first term going to be? What's 2x squared? 4x squared. Great. How do we get that middle term? You go 2x times 3. You multiply these two things together. And then do what to it? Not square it. You got to multiply the two numbers together, the a and the b together, and just times it by 2. What's 2x times 3? 6x times 2? 12x. Where's the third term going to come from? 3 squared. What's 3 squared? 9. Done. It really is that simple. You can go 5x minus 1 squared. Right to the answer. What's 5x squared? What is 5x squared? 25x squared? Great. Now we got to get the middle term. What is 5x times negative 1 times 2? Times these two things together and double it. Negative 10x. 2 times 5 times 1, right? So negative 10x. How do you get the third term? What's negative 1 squared? Negative 1 times negative 1, 1 times 1, 1. Can you always, if you're doing a problem like 6x minus 3 squared, are we allowed to write this out, 6x minus 3 times 6x minus 3, and FOIL that out? Absolutely. I'm not saying you can't do that. What I'm saying is I don't really want you to be able to have to do that. I want you to be able to do these faster and easier. So what I'm saying is I want you to be able to go, oh, that's just a perfect square trinomial. 6 squared, that's 36, x squared. 6 times 3 is 18. 18 times 2 is 36. That'd be a negative. So that's my middle term. Negative 3 squared, positive 9. There's my answer. I'm saying there's no need to FOIL it out. I'm saying this is the long way of doing it. There's a faster way. But you have to remember how you get each of the three terms. The first term is just the first term squared. The last term is the last term squared. And then how do you get that middle term? You multiply these two numbers together and then always times it by 2. And why do you always times it by 2? Because when you do FOIL this and you get that 36x squared, the reason we always multiply it by 2 is we would, after multiplying this one, we'd have negative 18x. When you do the outsides, when you multiply the insides, you'd have another negative 18x. So you're always going to have 2. In these kind of problems, the middle two terms, you're always going to have 2 of them, and they're always going to be the same. That's why we multiply by 2. Does that make sense? Easy? All right, on a sheet of paper, everybody try one. Ready? I'm putting the x on the backside. 4 minus 2x squared. I don't want you to write it out twice. I don't want you to actually FOIL that out. I want you to be able to go right from there, right to the answer. This is one that I don't actually want you to show your work. Normally I do want you to show your work. This one I want you to be able to go right to the answer. What's the first term? 16. Where'd you get that? 4 squared. What's the second term? So you went 4 squared. That's how you got the 16. How are you going to get the second term? You multiply these two together, so you got to do 4 times negative 2x, which is negative 8x, and then what? So what do you get? Negative 16x. How do you get the third term? Negative 2x squared, which would be? Negative times a negative is a positive 4x squared. This is the answer. And again, I don't want you to FOIL these. I really don't. Can you always FOIL them? Yes. Can you FOIL them to check your answers? Yes. But I want you to be able to just take these and go, oh, all I do is square that one. That's 16. And then I times the two numbers together and times it by 2. That's how I get the middle term. Square the second, and there's my third term. What would 6 minus x squared be? This isn't stuff you should type in your calculator either. What's first term? 36. Okay, 6 squared. What's the second term? What's 6 times x negative x squared? That's just negative 6x squared, right? Then what? What do you always have to do as well? You times them together and times it by 2. What's 2 times 6? Negative 12x squared. And then, how do you get the last term? Square that one. What's negative x squared squared? Negative times a negative. Will this, in these kind of problems, will this third term ever be negative? No, it'll always be positive. Why will this always be positive? Because a negative times a negative is a positive, and a positive times a positive is a positive. No matter what, this term has to be a positive term. All right, ready for a hard one? Yeah, here we go. 5, no, I'm going to add some. 5x minus 3y squared. You should be able to give me the first and the third term instantly. 25x squared and what? Positive 9y squared. Those are the first and the third. The middle term is the harder one. But how do you find the middle term? You multiply the two numbers together, which is negative 15xy, and then just do what? By 2. What's 15 times 2? Would it be positive or negative? Negative. 30xy. I want these to be easy. I want you to look at these types of problems as, oh, that's actually really easy. There is a really nice little shortcut for these, where if you go 2y squared minus 7x, and I square that, I want you to go, oh, that's easy. 2y squared, that's 4y to the fourth. And then I'd square this one, and I'd get positive 49x squared, right? And then how do you find the middle term? Oh, you just multiply these together. 2 times 7 is 14. What's 14 times 2? 28. That's a negative, so it'd be negative 28, and I'd have an x and a y squared. Done.
So when do you put the squared on the answer and then not?
So where did I get this 4y to the fourth? Where did that come from? I took the 2y squared, that term, and I squared it, right? So, yep, 2 squared is 4. Powers raised to powers, you got to multiply, right? Where did this term come from? I took the 2y squared, I times it by the negative 7x, right? And I multiplied it by 2. So with these, is there any adding the x, or is there any combining the exponents? No, it's just I have a single x and a y squared. And then it was just a matter of what's 2 times negative 7 times 2. Where did that one come from? That came from the negative 7x squared that. And then negative 7 squared is positive 49. X, yep, that one has to get squared. Does that make sense as far as the exponents go? I really do. I want you guys to be able to just take 7x squared y minus 4x. And I want you to be able to go, oh, this number, this 7x squared y squared would be 49 x to the fourth y squared. Yes? And then I personally do the third one next. What's 4x squared? Well, it'd be 16x squared, right? Now, times these two numbers together. What's 7 times 4? 28. Double it. What's 28 times 2? Or 28 plus 28 it'd be negative 56, right? Because I got a positive times a negative, it'd be a negative. Now, when I multiply these together, what do I do with my exponents? When I do 7x squared y times the 4x, what do I do with these exponents? Don't you add them? So how many x's am I going to have attached to this? 3. How many y's am I going to have attached to this? 1. Make sense? That's how you do perfect square trinomials. Okay? Are we good with those? Now, the next one is slightly different. Instead of taking a number like 2x plus 3 times 2x plus 3, we're going to do 2x plus 3 and 2x minus 3. When the numbers themselves are the same, the 2x's are the same, the 3's are the same. But one's a plus and one's a minus. Okay? FOIL this out. What do you get? 2x times 2x is 4x squared. 2x times negative 3. Negative 6x. 3 times 2x would be plus 6x. And then 3 times negative 3 is negative 9. What do you get? What's my final answer here? 4x squared minus 9. Because what happens to the middle term? All right, well, let's see. Let's try another one. Let's say I gave you, what's your favorite number? 12x. And give me another number.
8.
All right. So 12x plus 8, 12x minus 8. Okay? What is 12x times 12x? 144x squared. 12x times a negative 8 would be a negative 96x. And we got 8 times 12x, which would be a positive 96x. And then 8 times negative 8 would be negative 64. What's my final answer? 144x squared minus 64. What's happening here? The middle terms are always canceling each other out. The middle terms are always canceling each other out. This right here is what is known as a difference of two squares. Why do you think we call it a difference of two squares? What's the word difference mean? If I say, what's the difference between your grade and your grade? What are you going to do with those two numbers? What's the difference mean? Think the very first thing we did this year. Remember we wrote the equations from the words? When you see the word difference in an expression, do you add, subtract, multiply, or divide? You subtract. It's always going to be subtract here. The difference of two squares. This is what we call a perfect square. This is what we call a perfect square. This is a difference of two squares. What that looks like, whoa, that's not the D I drew. Is basically when you see a number plus A plus B times A minus B, when it's the same numbers. Are the first numbers exactly the same? Yes. Are the second numbers exactly the same? No. One's positive and one's negative. When you see this, it will always, 100% of the time, FOIL into A times A is A squared. B times B is B squared. And it'll be minus. Because what will happen 100% of the time when you FOIL these out? The middle terms will always cancel. It's only going to happen when it's perfect like this. But we call this a difference of two squares. Okay? And these are problems that really should be super easy. When you see a problem like 7x minus 3 times 7x plus 3, I want you to go, oh, that's the difference of two squares. What's 7 squared? What's 7 times 7? 49. And then x squared, right? 7x times 7x. What's 3 times 3? 9. Minus 9. Done. Do you worry about the middle terms here? No. We don't even care about the middle terms because we know they will always cancel out. Okay? Does that make sense? So there's two special binomials that we like to talk about. One is the difference of two squares. The other is the perfect square trinomial. Are we good with those? All right, everybody take a look at page 505. Come on, guys. Abby. 505. Take out a sheet of paper. Let's start your homework. 505. Take out a sheet of paper. Huh? I haven't told you that yet. All right, number 3. is this a difference two squares or a perfect square trinomial? That's a perfect square trinomial. Because is it 2 plus x and 2 minus x, or is it 2 of the exact same? 2 of the exact same. So, this is where you got to find the 3 terms. How do you get the first term? What's 2 squared? How do you get the middle term? You multiply them together and times them by 2. What's 2 times x? 2x. Times 2? Plus 4x. How do you get the third term? X squared. And there is your answer. Let's try number 6. What's 5x plus 9 squared? What's 5x squared? 25x squared. Plus what? How'd you get that? Times them together. 5 times 9 is 45. Times 2, 90. And then the last term would be 81. Easy? Every third. Do the next 2 real quick. And then I want to check number 15 with you. What'd you guys get for 9? X squared minus 4x plus 4? Good. Anybody get 12 yet?
Why do you stare at me like that?
Because you're staring at me. Anybody get 12? Oh,